All right, 5.3 day 2. So we have 3 objectives we are covering today. The first objective is I can identify a polynomial as odd or even from the graph. The second is I can determine the number of real zeros from a graph. And the third is I can describe the end behavior of a polynomial from a graph. So we first need to cover a few definitions before we get into our examples. The first definition that we're going to cover is odd degree functions. So when something is called an odd degree functions, that means that it will always have an odd number of zeros. And that means that an even degree function will always have an even number of zeros, or the other option is it could have no zeros at all. So be careful. Now let's think about this a little bit. I'm going to skip that for a second and look down here. We've talked about the degrees. The degrees means the highest exponent. So when we have a highest exponent that is odd, that means it's an odd degree function. When the highest exponent is even, that means it's an even degree function. So if something had a degree of 0, like y equals 5, that would be a degree of 0. If something had a degree of 1, like y equals 2x, that would be a degree of 1. Now remember, we talked about the number of real zeros that we would see with even and odd degree functions. So these are odd. So those 3 functions are considered odd degree functions because they have a degree that is odd. 1, 3, 5, and obviously there's more. So let's take a look at the number of real zeros here. Zeros, that you may recall, are the places where they cross the x-axis. Now we don't really think about a linear equation having zeros, but it does. It's your x-intercept. So there is one place that the degree 1 crosses. There's 1 real 0. Degree 3 crosses in at most 3 places because it's an odd amount. And then a degree of 5, the most number of times that it can cross is 5. Now it's said that all the odd degree functions have an odd number of real zeros. So that means, remember I said the most number of places it could cross for the degree of 3 would be 3 places. That means that it could have only 1 zero. Oh, my lights went out. I must have stopped moving. So it could have 1 0. Degree of 5 means that it could have exactly 5 zeros, but that's the most that it can have. It could also have a degree, it could also have 3, or it could have 1 0, because remember, it has to have an odd number of zeros. And we'll talk more about that later on in the chapter. That's not for a couple of weeks. Right now, the main thing you need to be able to see is if I have an odd number of zeros, that means it's an odd degree function. If I have an even number of zeros, that means I have an even degree function. Or if it doesn't cross at all, like for example, a parabola that never crosses the x-axis, that would also be an even degree function because it can have no zeros at all. So that makes these last few here even degree functions. So an even degree function of 2 can have at most 2 places where it crosses the x-axis. Even degree function of 4 would have at most 4 places it would cross the x-axis, or any even number below that. Let's talk about end behavior. End behavior describes what's happening at the ends of the graph. And there's a statement that I want you to remember that it's describing. And then this is the notation that you need to memorize for it. So the statement is, and that's what this notation means, as x approaches positive infinity, y approaches blank. As x approaches negative infinity, y approaches blank. And what goes in that blank will either be positive or negative infinity. So I'm going to go through the 5 functions at the bottom that we're going to talk about, not the constant one, because it does a little different. You can say end behavior for it, but in the interest of time. And we're going to write out what would be the end behavior for each of those. And let's see if we can come up with any sort of generalization for even and odd degree functions. So we said that our statement here is as x approaches positive infinity, y approaches, and x approaches negative infinity, y approaches. So you're going to say that for each of those. That's kind of the general statement that gets written for all things describing end behavior. So take a minute and go ahead and write those next to each one of these. Now, we didn't actually look at or determine anything yet. All we did was we took that notation that I said you have to memorize, and I just wrote it for all of these to kind of save us time. So as soon as you see a question asking, what is the end behavior? Describe the end behavior. You're going to write what I just wrote in purple on the answer blank. Now we have to actually find the end behavior. So when it says as x approaches positive infinity, that means that we are looking at the right-hand side of the graph because that's where the x's go up. That's where the x's get closer and closer to positive infinity. So here, the right arrow is the one that we're going to look at. Is that right arrow pointing up? Or is that right arrow pointing down? Because that's what our y's do. They either go up or the y's go down. This arrow is pointing up, so we are going to say that y is approaching positive infinity. In regular English terms, we are saying as x goes up, y goes up. But we have to use notation correctly in this class. So we say as x approaches positive infinity, y approaches positive infinity. So for x approaching negative infinity, that is going to be our left arrow because that's where the x's go down. That's where the x's are getting closer to negative and negative and negative and negative. So is this arrow going up or is this arrow going down? It's going down, so we are going to say that y is approaching negative infinity. So each time that it asks about x approaching positive infinity, we're going to be looking at the right arrow. Each time that x approaches negative infinity, we're going to be looking at the left arrow. Let's look at the sample quadratic function. So for the right arrow, that's x approaching positive infinity. It's pointing down, so that means y is getting closer to negative infinity. Now the left arrow, As x approaches negative infinity, that's the left side, it's pointing down, so that means that y is approaching negative infinity. Now remember, be thinking about any patterns for the evens and the odds and their end behavior, because there is one. Let's look at another odd one. There's the right arrow. It's pointing up, so as x approaches positive infinity, y approaches positive infinity because it's pointing up. Left arrow, as x approaches negative infinity, y approaches negative infinity because it's pointing down. Even degree function of quartic or degree 4. Right arrow, as x approaches positive infinity, that's the right arrow, positive. It's pointing up, so y also approaches positive infinity. For the left arrow, as x approaches negative infinity, that's the left arrow. It's pointing up, so y is also going to positive infinity. Let's look finally at the last odd one here. So the right arrow, as x approaches positive infinity, y approaches, it's pointing up, so it's positive infinity. As x approaches negative infinity, that's our left arrow. It's pointing down, so y approaches negative infinity. So take a look here at the differences between even and odd. If we look at our odd degree functions, so 1, 2, and 3, right here, your end behavior, one was positive and one was negative for the y values. One was positive, one was negative for the y values. One was positive, one was negative for the y values. Take a look at the even degree functions, though. Both were negative. Both were positive. The pattern that you're looking for is when it is an odd degree function, your y values or your end behaviors for the y's will always be opposite. An odd degree functions, the arrows will always point in opposite directions. That's true for every odd degree function we looked at here, and it's true for every odd degree function you will look at. Even degree functions, the end behavior points in the same direction, so your y values are going to be the same. So end degree here, or end behavior here, they're both pointing up. Y values are both at positive infinity. So we should be able to look at a graph without being told whether it's odd or even. We should be able to say, hey, this is odd or this is even, and we should be able to describe end behavior. So when we look at this first graph for part A, I notice right off the bat a couple of things point me toward whether it's even or whether it's odd. First of all, I look at the arrows. These arrows are pointing in opposite directions. The left arrow is pointing down. The right arrow is pointing up. So again, the first thing asks me to write and describe the end behavior. So we have to write that little thing that we have to memorize. As x approaches positive infinity, y approaches. As x approaches negative infinity, y approaches. That's just something we're memorizing as the beginning of the notation. Positive infinity is the right side of the graph. Negative infinity is the left side of the graph. And I see that these are pointing in opposite directions. When I look at the right arrow, it's pointing up. So that indicates that y is getting closer to positive infinity. When I look at the left arrow, it's pointing down. So that indicates that y is getting closer and closer to negative infinity. Now, these arrows point in opposite directions. So that indicates to me that this is an odd degree function. Another thing that would indicate to me that it's an odd degree function is the number of real zeros. 1, 2, 3, 4, 5. So the number of real zeros is 5, which is an odd number. That tells me it's an odd degree function. Let's do the same for part B, and then I'll set you loose on your homework. Part B asks you to describe the end behavior. That indicates we got to write the part down that I memorize first. That's not figuring out anything. That's just straight memorization. That's something that will not be able to be told to you on a quiz or test. So the first part is asking positive infinity. That's the right arrow. Negative infinity. That's the left arrow. When I look at both of these, they are both pointing up. They are both pointing in the same direction. And when it's pointing up, that indicates a positive infinity. And since they are both pointing in the same direction, that means that this is going to be an even degree function. The other part that points to this being an even degree function is the fact that it has an even number of zeros. There are 2. That's the end of 5.3, day 2. So your homework can be found underneath the calendar in the front of your note packet. If you don't have that page, you can come and get it up at the front in the black binder. I'll be checking homework when I return on Monday.